Welcome to Part 2 in the screencast series Refactoring to a Solid Foundation, whereby we investigate the solid object-oriented design principles by attempting to apply them to a refactoring effort against an existing software in order to understand how they allow us to achieve better, more flexible object-oriented design. In our past installment, we took a look at the S part of SOLID, the single responsibility principle. In this installment, we move on to investigate the O of SOLID, the open-close principle. The open-close principle, simply stated, goes like this. Software entities, classes, modules, functions, etc., should be open for extension, but closed for modification. This seeming conflict here would seem to be an impossibility. How on earth can a class or a module be open for extension and yet somehow at the same time closed for modification? Essentially, this is achieved by applying abstractions, implementing common interfaces, deriving from common classes, or introducing abstract-based classes as a mechanism for introducing abstractions into the relationship between our elements. This allows us to substitute one element for another. For example, a class that implements an interface can be replaced by another class that implements an interface, but the method that is provided for the interface can perform different behavior. So in this manner, modules can be extended, but not by modifying their source code. This allows us to change the behavior of a system without the possibility of introducing bugs by modifying existing code. Instead, we implement common interfaces derived from common base classes in order to allow us to change the behavior of the system by essentially substituting one module, one class, one function for another, in the process changing the behavior of our software. Let's now examine how we can apply this principle to our existing software project in order to understand its application to our design. Here we are in Visual Studio 2008. We have our solution open from our previous installment. Just so we can remind ourselves what the application does, I'm going to hit F5 and let it run. It opens up a console window, and of course it prints out what the application is busy doing. So the first thing it does is it gets data, then it formats the report for 8.5 by 11, then it prints the report to a laser printer, and then of course it says program ended. So we'll notice that a little difference here has been introduced since the last installment, where I've added the fact that presently the report formatter says format for 8.5 by 11, and the printing of the report says printing report to laser printer. So we've gotten a little bit more specific with the existing software, so that when we introduce our changes, as we will in a moment, it'll become obvious what we're trying to accomplish. What we're going to do is we're going to follow through the process that is going to be the introduction of the open-close principle to allow us to change the behavior of the software so that it will print to tabloid paper instead of 8.5 by 11 letter size paper. So let's get started all the way down at the level of the report formatter class. So the report formatter class presently has a single method called formatReport that basically spits out to the console the fact that it's formatting the report for 8.5 by 11. So what we want to do is we want to change the behavior of the report formatter in our application without modifying the existing code. So what we're going to do is we're going to introduce a brand new class. This one will be called Tabloid Report Formatter. We don't need the constructors, so let's get rid of that. We do need to make one slight modification, however, to the report formatter class. We need to take its public format report method and declare it virtual so that we can override it in a derived instance. So what we're going to do is we're going to derive tabloid report formatter from report formatter, and then we're going to override its format report method, like so. So the stub that Visual Studio gives us for the override of the format report method is just basically contains a call to the base class's format report. We don't want this, so we're going to comment it out, and we're going to replace it with our own behavior, where we're going to take and copy the body of the existing base class's method and change this so that instead of formatting report for 8.5 by 11, we're going to change this so that it says formatting report for 11 by 17. So we've taken and extended the behavior of the report formatter class so that now it behaves differently. We did make a slight modification to our underlying base class, so this code wasn't entirely closed for modification, but the modification was very, very minor. It allowed us to override the base class's format report method with the derived class tabloid report formatter's own implementation of format report. So the next thing we need to do is walk our way up the hierarchy. So report formatter now has a tabloid report formatter. We now need to look at the report printer class. and do exactly the same thing. So just as before, we do need to make a slight modification. We're going to declare the print method for the report printer to be virtual so that when we derive something from it, we can actually go on ahead and override that. So we're going to say tabloid report printer, like so. We can get rid of the constructor that's empty, and then what we're going to do is we're going to override. So just as before, we're going to override. In this case, we're sorry. Would help if we actually derived from the base class. So we're going to derive this guy from report printer, and then override the print method. Again, we don't want the base print method. We want our own print method. We're going to start by copying this from the base class, and then we're going to modify it. So the data access behavior is fine. We want to print the same data, so we can leave that alone in the derived class. However, the report formatter that's here is actually the wrong report formatter. What we want is, instead of the report formatter, we would actually like this to be a new tabloid report formatter, like so. Then what we'd like to do is call format report and have the whole thing run. However, instead of printing to laser printer, let's imagine that what we'd like to do here is pretend that our tabloid printer, instead of being a laser printer, is, let's just say, a dot matrix printer. There aren't too many dot matrix tabloid printers out there, but let's imagine that this was one. So now we have a tabloid report printer, which derives from report printer, and we have overridden the print method in the derived class so that we're still using a report formatter, except this time our report formatter is actually a tabloid report formatter. So the last change we need to make to this at this point is to come back into our program now, and the whole point of this was to be able to change the way this thing worked. So instead of a new, we do have one more to do. Let's deal with the report. So now what we need is we need ourselves a report replacement. So let's take the print method again, and let's declare it virtual in the base class. We're going to introduce a new class. In this case, it's going to be called tabloid report, like so. Just as before, we can get rid of the empty constructor. We don't need it. Tabloid report is going to derive from report, like so. And then what we're going to do is we're going to override the print method. Again, we don't want the base class's print method. We'd like our own. But let's take this just to save ourselves some typing and copy and paste it over here. We still have a report printer. However, in this case, it's the tabloid report printer. It's no longer just report printer. However, it's still got a print method that we can invoke, and that's exactly what we're going to do. So now, our last change is we need to come into our program's main method, and instead of declaring a new report instance, we need a tabloid report instance. Our tabloid report class also contains a print, and this should allow us, when we hit F5, to run, we do have one slight problem, which is that the rest of these classes are all internal, so let's see if we can fix that problem. There we go. And so what we see now is that what we're getting is exactly a change in behavior. So we're still getting data, we're still formatting a report, and we're still printing a report, but now instead of formatting the report for 8.5 by 11, we're formatting the report for 11 by 17. And instead of printing it to our laser printer, instead we're printing it to our dot matrix printer. So what we see here is that we have extended the behavior of our software system without making modifications to the existing code in many ways. We did make some minor modifications to the existing code. For example, in the base classes, we needed to go on, obviously, and declare the public methods virtual so that the derived classes could override them properly. However, you'll notice that none of the existing software has actually been modified. Right? This is still the body of the print method in the report printer class. So we're leaving that intact. That allows us to say that we're not going to introduce new bugs into the existing behavior of the existing report printer class because it is closed for modification. We are not actually opening up the class and changing the code. We're extending the behavior of the system and changing it. So these modules are open for modification. We're changing the way the software behaves, but we are not doing so by modifying existing code. We're doing so by essentially opening the things for extension, but keeping them closed for modification. And that, of course, is the essence of the open-close principle. And that takes us to the end of this installment of refactoring to a solid foundation.